This video is about section 1.6, absolute value equations. The distance between 2 points A and B on a number line is given by the absolute value of A minus B or the absolute value of B minus A. So absolute value determines distance. So that is the distance between 2 points on a number line is the absolute value of their distance. Write an absolute value expression that represents the distance between the two given points on a number line, then simplify. So if we make negative 10a and 3b, and we do the absolute value of a minus b, that would be the absolute value of negative 10 minus 3, and that would be the absolute value of negative 13, which would just be 13. And we can also do this the other way. The absolute value of b minus a would be the absolute value of 3 minus negative 10. So the absolute value of 13 is 13. So either way, the distance is 13. Here we've got the absolute value of the square root of 3 minus 4, and this absolute value of 4 minus the square root of 3. And I'll just get a decimal for that in my calculator. And for this first one, I'm going to get the absolute value of negative 2.27. And I'm just going to double check that I get the same thing when I do 4 minus the square root of 3. And I do get the positive absolute value of 2.27. So both of these would just be 2.27. Next, solve the following absolute value equations. So for this first one, zoom in, add 4 to both sides. And this says the absolute value of r is equal to 16. So that means that r could be 16 or r could be negative 16. And really quick, that's because if I take the absolute value of negative 16, I get 16. The absolute value of 16 equals 16. So that's kind of like distance from 0 for both of those is the same. All right, for this middle one, if we add 5 to both sides, we get 3 times the absolute value of x is equal to 15. Divide by 3, and we have the absolute value of x is 5, so that means the distance of it from 0 to x is 5, so that could mean x is equal to 5 or x is equal to negative 5. I meant to write these as sets, so the set solution would be negative 5 comma 5. And then back over here, the solution would be negative 16 comma 16. Doesn't really matter the order, but usually they do smallest and then biggest. All right, last one for this section, I'm going to add 2 to both sides. And I get the absolute value of y minus 4 is equal to 8. So that means the distance that y minus 4 is from 0 is 8. So we're going to have y minus 4 equals 8. Or y minus 4 is equal to negative 8. So if I add 4, I get y equals 12. And over here, if I add 4, you would think it'd be negative 12, but it is negative 4. So for this one, the solution set would be negative 4 and 12. All right, for the next section, same thing, just a little more complicated problems. We're going to divide by 3. You might be tempted to distribute here, but because of the absolute value, it gets very tricky if you do that, so I try to avoid doing that at all costs. In between the 3 and the absolute value, there's a multiplication, so to move the 3 to the other side, we're going to divide by 3. And we're left with absolute value of 5 minus 2t is equal to 10. And here we have 5 minus 2t equals 10, or 5 minus 2t is equal to negative 10. When I solve these, I get off my page a little bit. T is equal to negative 5 over 2, or 2.5, sorry. 15 over 2, or 7.5. So my solution set is negative 5 over 2, or 15 over 2. All right, for this one, I'm going to subtract 12 on both sides. And I've got negative 8 is equal to the absolute value of 4x minus 4. And this is kind of an interesting one. So we have the absolute value of something is equal to a negative. And so this one has no solution. And that is because you cannot have negative distance. That's not a super mathy way to say that, but absolute value is kind of like distance, and you can't really have negative distance. Okay, last section, there are two absolute values here. So for this first one, we're going to have 5x minus 7 is equal to 3x plus 1, or 5x minus 7 is equal to negative 3x plus 1. And notice here we're making that whole side negative on the right by putting a negative and parentheses. All right, let's solve the first one first. Minus 3x. We've got 2x minus 7 is equal to 1. Add 7. 2x equals 8. Divide by 2. Our first solution is 4. Second one, we need to distribute the negative first. So we've got 5x minus 7 is equal to negative 3x minus 3. I'm going to add 3x. And for time's sake, I'm going to add 7 at the same time. So I've got, oops, not 2. I've got 8x on the left equals 4 on the right. And I'm left with x equals 1/2. So for this problem, my solution set would be 1/2 and or 4. So both of those numbers would make that absolute value true. All right, next one, we're going to have 2x minus 1 equals 1 minus 2x, or 2x minus 1 is equal to negative 1 minus 2x. And notice here, we add a negative to the whole side. Now, really quick, we could put a negative on this side, and the solution on this one would be the same. It doesn't really matter. We just chose to make the right side negative. Okay, let's solve the first one. We're going to add 1 to both sides. And at the same time, I'm going to go ahead and add 2x to both sides to get it all done in one step. So these cancel to 0, as well as these. So I've got 4x on the left and 2 on the right. Oops. I'm going to divide by 4. And I get x equals 1/2. On the second part, we're going to distribute the negative. So I'm going to have 2x minus 1 is equal to negative 1 plus 2x. I'm going to go ahead and add 1 to both sides and subtract 2x to both sides. These cancel, and these cancel, so this is kind of crazy. We get 0 equals 0. And what this means is because, I'll change colors, because 0 equals 0 is always true, any value of x will make 2x minus 1 absolute value equal to 1 minus 2x also true. So for here, our solution set is all real numbers. Now, if in the end, we've seen problems like this before, but if in the end we ended up with like 0 equals 5, those are not true, so that one would be no solution. Okay, that's not what we have here, but that would just be an example.